Hi, my name is Cole Fontaine. I'm from IB Physics, and I will be talking about what nuclear power is. I contributed to this project through research of what nuclear power is and doing some of the video and also the mind map. I was interested in this topic because it has been growing since the 1940s, and there's been a lot of concerns with the safety of nuclear power.
Hi, my name is Sam Wilheim, and I'm from IB Sports Science. In this project, my role was to find the pros and the safety of nuclear power. I contributed to the project by building background research on the safety of nuclear power, and I also I filmed my section of the video. I was interested in this topic because I've really heard a lot of controversy on the topic, and I just really wanted to build an opinion of my own, in a sense, throughout this process.
I'm Jamie, and I'm from IB Biology, and I'm going to be talking about the risks of using nuclear power. I contributed to part of the research on the topic, writing the script, and filming, and I was interested in this topic because it's a field that's still growing and potentially a source for a lot of energy.
Nuclear power is used to provide electricity to many countries, as well as a main fuel source for marine propulsion for ships and many navies. It was developed in the 1940s as a source of creating weaponry. Now there are over 430 commercial nuclear power reactors up and running in 31 countries, 99 alone in the US. Additionally, there are 70 reactors under construction throughout the world. The way nuclear power works is neutrons collide with uranium atoms, which splits them. The split then releases the uranium atoms that go and collide with other atoms, this causing a chain reaction. The chain reaction is controlled with control rods that absorb the neutrons.
So one of the main arguments against nuclear power is the amount of radiation it releases on a daily basis. So I found this organization called UNSCEAR, and it consists of 21 scientists nationwide. They went along to disprove this point by saying the Earth itself has a natural background radiation of about 240 millirem, which is just a unit of measurements. And then it went on to say that the largest source of man-made radiation is about 40 millirem. So this just goes to show that if people have been living on this Earth for a very long time with natural background radiation, 40 million millirem is not going to do much compared to 240 millirem. So they're just trying to tell us that it's really safe for the time being, and there's nothing really to worry about. So another point that is used against nuclear power is basically the consequences if there was an accident. According to worldnuclear.org, this is not an issue. They say that nuclear power sources are made to prevent accidents, and that even if there was an accident, new advancements have made it so the human consequences are not fatal. In addition, there have only been 3 major accidents total so far, and there are about 17,000 nuclear power plant operations operating around the world. We have really improved our how we handle the nuclear plants. So for example, we now have barriers that protect against spills if an accident occurs. In addition, operators are much more trained to deal with spills and deal with the power plants. So in the event of an accident, we have people that know what to do, and the barriers should protect it also. In conclusion, nuclear power plants are very safe for the time being because it has a really low chance to spill in the first place, and if it does, the damage should be minimal. So it should be very safe.
Dr. Bryce Smith from the Institute for Energy and Environmental Research argues that nuclear reactors risk public health, the environment, and the security of the nation. In particular, if deployed on a large scale, it would make catastrophic reactor accidents more likely and increase the amount of radioactive waste they have to deal with, as well as the prevalence of nuclear weapons. The chance of a nuclear reactor experiencing a meltdown in 40 years of operation is nearly 1 in 3. As the Nuclear Regulatory Commission renews licenses for 20 to 40 more years of operation, that risk goes up. Many plants that try to replace parts that are subject to age-related failure often run into problems in which the parts break or degrade. The two biggest nuclear power plant accidents in history were the ones in Chernobyl and Fukushima. In 1986, a flawed design of the reactor and no safety procedures resulted in a sudden power surge that eventually led to an explosion of the plant. The fire went on for 10 days and released a significant amount of radiation into the atmosphere. 28 staff and emergency workers died from exposure to the radiation and thermal burns. This was also responsible for 7,000 cases of thyroid cancer in children, and almost 30 years later, 10,000 square kilometers are still unusable.
Here in the mind map, the cons connect to pollution, health risks, and accidents. Both the health risks and pollution end up connecting through radiation and its effect on cancer. Next is the pros, which connects to the amount of radiation released. Ways accidents are prevented and the large amount of electricity produced. This large amount of electricity produced connects with the nuclear power section. This then connects with how it is made with uranium and the chain reaction.